Good morning, ladies and gentlemen, and welcome to another statistics lesson. This lesson we're going to be talking about z-scores as distributions. Nice little formula here, just happens to say that z equals x minus x bar over s. Well, anytime I see symbols, I like to know what they are, and I'm betting you do too. So, in this case, what I'm going to tell you is that x happens to be the data that you're converting, whatever that data happened to be in its raw form. X bar is the mean of that data, and s in this case is the sample's deviation. Let's take a normal distribution with mean of 175, and if you can tell by the way that the lines are separated, they're separated by about 75, so that's going to be your deviation in this case. If a value happens to already be at the mean, when you're performing your z-score calculation, it's actually going to become 0. So just for instance, let's say that you take 175 minus 175, that gives you 0. And by now you've probably learned that anytime you divide 0 by anything, you get 0. Taking another look at this, let's say that we have a value that's a deviation above the mean. Well, if it's one deviation above the mean, doesn't it make sense to have it have a value of 1? So let's see how the z-score manages to accomplish this. For this example, 250 minus 175 happens to be 75. 75 divided by 75 gives you the 1 for the z-score that we're looking for. One more example of this. Let's take a look at one that's below the deviation by 75 in this case. So if it's one step below, it should be one step below, and we use negatives to reveal below, so negative 1 looks good in this case. Let's see how the formula actually makes it happen though. 100 minus 175 is negative 75. Negative 75 divided by 75 gives you the negative 1. So one more look at this, and then look at what the z-score actually is supposed to look like. Once you standardize a normal curve, you get mean of 0 and a deviation of 1, 2, 3 as you go to the right, and negative 1, negative 2, negative 3 as you go to the left. It looks a lot like a number line. So one of the effects of having a standardized normal curve is that you have a 0 at the center. Another effect is that it actually does not change the shape of the distribution. If you actually started with one that wasn't normal, then the one that you get done when you finish your z-scores, it won't be normal either. So if you want normalized data, you've got to start with normalized data. And also you'll notice that the z-score does actually change the spread of the distribution. Before it used to be a spread of 75 for each standard deviation, and now it's down to 1. So that's just a little introduction on z-scores and exactly what they do with distributions. Hope you have a great day.